Thank you. It's a pleasure to be here, and I'm looking forward to talking about what I think is one of the largest problems in big data and analytics today. And we're going to cue slides. No? No? Oh, here it is. Sorry. Self-service. The big problem that nobody wants to talk about, the dirty little secret of data in the enterprise, is that much of our data is siloed into all kinds of different little nooks and crannies in our enterprise. Over the last 30 or 40 years, most of us have spent time, energy, and effort automating business processes and building systems that lock the data into the areas where those business processes function. But as we start to consider now doing broad analytics across the enterprise, what we're faced with is a mass of different tools. Many of those tools we're all familiar with as a part of the big data movement, Hadoop and all of its spawn. And the problem is that we don't really have a clearer picture of the simple data that exists, knowing who are our customers as a company, who are our suppliers, who are our employees. This basic information that everyone should know isn't available at the fingertips of most employees in large companies. And this is a huge challenge because the aspiration of big data and analytics is to achieve these transformational analytic outcomes. And I'm going to talk to you today about a couple of these transformational analytic outcomes that we've experienced working with our customers who've cleaned up their data. And many folks that like to talk about predictive analytics and modeling and all kinds of fancy things, we believe that at the core of the work required in order to achieve these transformational analytic outcomes is cleaning up your data, organizing your data, and doing so through the lens of a broader organization, a broader company. So one of our largest customers at Tamr is GE. And GE spends about $60 billion US dollars a year buying things from all of their suppliers. When we started working with GE, they asked one simple question. And that question was, are we getting the best terms every time we buy something across all of GE? It seems obvious, but it was a very hard question to answer because they have more than 300 different ERP systems and more than 2,000 different procurement systems. And so trying to understand if you're buying just one 2-centimeter brush ball bearing, if that you're getting the best price you can get, really depends on being able to query very broadly across all of these systems. So by bringing all of that data together, cleaning it up and unifying it, we were able to realize a spend optimization at GE in excess of $500 million on their $60 billion of direct spend. And so when people talk about big data and analytics and the potential impact, they usually don't talk about these kinds of savings. Right? We're talking about saving hundreds of millions of dollars, $500 million for a large global 2000 company. We're not talking about Hadoop. I'm not talking about tools. I'm not talking about visualization interfaces. I'm talking about saving real money for a really large company. And this really should be the aspiration of all of these tools and all of this work that we're doing for the large organizations to either help them save money, as we did at GE, or to help them sell more. To a certain extent, if we're spending all this time, energy, and effort, it should have one of those two benefits for any one of these organizations. So another one of our customers is Toyota Motors in Europe. And in Europe, they operate across many different countries, more than 30 different countries. And in each country, they have dealerships. Each one of those dealerships has an idiosyncratic dealer management system. And so the data generated from all those systems comes in a very, very different formats. And Tamr was asked to take all the data coming from more than 3,000 different dealerships and create a unified view of all their customers across Europe. So that if someone buys a car in Barcelona and moves to Paris, the dealership in Paris will know who that customer is, what their service history is, and what kinds of things to recommend that they buy or not buy. So creating this very simple unified view of customers, even though it's very intuitive and we believe that every customer probably should have this already, doesn't exist in most large organizations because all their data is siloed, just like the siloed data in the Toyota dealerships. Another one of our large customers is GSK, the large biopharmaceutical business. And at GSK, they have clinical data. So when they run tests for new drugs, trials for new drugs, they put those drugs out into these clinics. The clinics generate data on how those drugs performed or not and all the specifics about each patient. And then when that data comes back to GSK, it comes in the form of tables, tabular data. Cleaning and unifying all those different tables from all those different clinics is a very, very difficult task. And then preparing that data to submit it to the FDA in a format that the FDA finds acceptable and is standard is a very challenging process. We've taken what used to be a 6-week process for taking the data from their statistical models and submitting it to the FDA. We've taken that 6-week process down to less than a day. And you can do this when you automate the preparation of your data. So the Fortune 2000, or the Global 2000, is all struggling with this challenge associated with data and analytics. And the quality of their data and the integration of their data is like this iceberg. And it's very, very challenging as a problem, but it's also the most important thing. We like to say, as the quote here from Andrew, that algorithms are very inexpensive. Models are very cheap, right? But the data is actually where the value is. If you look under the covers at the large internet companies, many of them believe that their core asset is the data that they generate every single day and that their users generate. We believe that all businesses need to start to view their data as a fundamental asset. And when you do that, you have to catalog the data, understand what data you have, where it comes from, and you have to understand who's using it and how they're using it. And you need a system like Tamr in order to organize that. So Tamr's system allows you to take these very disparate and very siloed data sources, bring them together, unify them so that unified data can be consumed either in analytics, visualizations and models, or in this very wiki-like format where we present the data as almost a wiki page that's everything you want to know about a customer, a supplier, an employee. All the information from across the organization comes together into this one wiki-like page. In creating that, it's very important for these companies to have this resource because it's an expectation of modern employees. When they go home and they use the modern internet, they are curious about a person, an actor, or anything, they can go to Wikipedia and get the answer. Right? They come into the office in the morning and they have a question about a customer. What do? They have to call someone. They have to look things up in all these coded databases. Shouldn't be like that. They should have access to the information, basic information that they need every day. And so making data available in these wikis is very important. And then the third method for accessing this unified data is through APIs, other machines. Oftentimes this is in the interest of enhancing existing data warehouses and data marts that might be out there that are incomplete, that don't have all the source data. So what's different about what we do from some of the traditional vendors, so the traditional way to do this data integration and data cleaning is using deterministic tools. And many of us here are old enough to remember the early days of Yahoo. So Yahoo on their homepage had on the right-hand side, or on the left-hand side, they had this list of travel sites and leisure sites and financial sites. Those were originally manually curated by thousands of library scientists that were employed by Yahoo. And then Google came along and built a model-based system that indexed all the websites and matched them to key search terms that users were entering. And that model-based approach replaced the manual curation of the web's data that Yahoo had employed. And so we believe there's a very similar dynamic going on here inside of large enterprises where they've got lots and lots of this tabular data that people are interested in consuming. They can't consume it in part because the traditional approaches to doing so are very top-down deterministic, the way that Yahoo first tried to curate the web, and is going to be replaced now by Tamr's approach, which is to use a probabilistic model-based approach to organize and curate all the data across an enterprise. And what this enables you to do is add lots of new data sources very quickly. The same way that Google indexes the entire web every single day, we believe this Tamr service, the role it plays in the enterprise is to organize and curate this data so people can find it and discover the data that they need when they need it and understand how it's changing. So the Tamr system functions not as a completely autonomous tool. It's both machine-driven, so we use models to organize how all these tables of data are related to each other, and we also use human feedback on whether or not the guesses that have been made by the machine are accurate or not. And we believe this is a really essential element in organizing a company's data. The way you train these models is actually by using and engaging human beings in the development of these models and answering simple questions. Is this customer the same as this other customer? Right? Is this attribute in this database the same as this other attribute? And the machine can take guesses as to what it is, but it really needs feedback from humans to validate that. And then over time, if you get enough feedback, it becomes, in an active learning model, you start to develop the ability of the model to behave as if it's unassisted. It doesn't need as much help from the humans because it's seen all the different permutations. This is the way the Tamr system works. So what does this actually look like? There's really three core functions in our system. And these are the same functions that any human would have to do if they were trying to bring lots of disparate data together. The first one is mastering records, determining is this record over in this database the same as this other record? This is also called deduplication, right? Or matching records. The second function is classifying items, determining whether things are classified the same or different, and resolving all the taxonomical differences that different databases might have in terms of how they refer to various attributes, various fields. The third method in the system is mapping attributes. Is this column of data over here the same as this other column of data? And the thing that we do at Tamr that's unique with these three approaches, many of these three things have been tried over and over. This is a problem these are problems that are as old as time. But one of the things that's very different is that we do these things at very large scale. So assuming many thousands, even hundreds of thousands or millions of data sources, many millions of attributes, and very, very large scale, billions of records. And so having a system that scales out enables you to do these things much more broadly and much more dynamically than was ever possible before. So let me take you through a case study of how this manifests. So I mentioned earlier this idea of these enterprise wiki pages, everything that a company knows about a certain thing. So this is an example from GE's website, internal website, their intranet, where they've got all their information about their largest supplier here. This is Grainger, the big industrial distributor. And so you'll see there's lots of different things on this website that represent everything that GE knows about Grainger. And it's kind of a landing page for anybody that wants to do anything with Grainger at GE. And this includes things that are very informational, the posts and the different people that are involved, but it also includes analytical things like the total amount of money that GE spends on Grainger, the number of quotes that have been generated from GE to Grainger. And of course, these are not real numbers. But you get the idea that the goal is to create these landing pages, again, bringing into the enterprise an experience that's very similar to what people experience on the modern World Wide Web. There's also an advantage here over time as you start to understand these key entities inside of a large organization. First, at GE, we started with their supplier information and organizing all their suppliers and deduping all their suppliers and all the sources of data about suppliers. And then we moved on to parts, the parts that are bought from those suppliers. And then we moved on to GE's customers. And you start to ask interesting analytical questions that go across these core entities. For example, who are my customers that are also my biggest suppliers? This is very valuable to know when you're going in to renegotiate with a supplier and you've got a strategy to renegotiate with them. And if that strategy is a scorched earth kind of a strategy, and they're also your biggest customer, well, that may not create the outcome that you desire. Right? You may save a lot of money in terms of what you buy from them, but they may decide that they don't want to buy as much from you. And just understanding these basic things about how this data is integrated across the company creates all kinds of opportunities to deliver these transformational analytic outcomes. So another example of a project that we worked on with GE was customer mastering. So this is the process of mastering all the customer data across GE in order to understand exactly who their customers are. And as they're marketing and primarily trying to cross-sell and upsell to those customers, having an integrated view is very, very valuable to understand all the things that that customer has purchased from GE in the past across all the various divisions, on many, many times the things that they haven't purchased yet from GE. Another use case at GE for this unified data is in logistics. We're doing a very large project with GE with regards to the Port of Los Angeles and optimizing logistics around the Port of Los Angeles. And this primarily depends on integrating many different data sources, not only from within GE, but from all the different constituents that participate in the Port of Los Angeles. Bringing this data together enables them to do analytics and see patterns in logistics and identify opportunities for optimization that they couldn't otherwise see. And they can only do this because they've got the data collected and organized in the right way. Additionally, there's tremendous opportunities to do supply chain optimization. So looking at data that supports the entire supply chain across all of GE's products and identify areas in those supply chains that can be optimized. Many of these optimizations depend on having good quality data that's integrated from many different sources. And having the muscles, the basic muscles that are required in order to integrate this data and just make it available empowers analytics that are previously impossible. So finally, I'm going to sort of close out with this example of spend optimization. So this was the example that I referred to earlier that saved GE hundreds of millions of dollars. And again, what they've done is they took a large number of these different data sources, thousands of different data sources of parts, the things that GE purchases. They bring all those data sources together. And the first optimization that we did was, are we getting the best price at GE every time we buy a given part? That one analytic alone in the first phase saved them $80 million, the second phase $300 million. And now, many hundreds of millions more that are being saved just by unifying the data and bringing the data together. No fancy modeling required, right? No big predictive models or any of this stuff, like just by cleaning and organizing their data and then viewing that data analytically from the perspective of all of GE, which is really the reason why these large companies exist. If GE can't get the best price every time they buy something, well, then they should just be a loosely affiliated set of separate companies, right? But if you're going to have these large organizations that have big brands and have this kind of ownership, they need to be able to deliver these kinds of optimizations. And those optimizations almost always start, first and foremost, with unified data. So that was the set of materials that I prepared, and I would be really happy to take some questions.
Andy, could you illustrate the typical implementation processes when when customer purchases your product?
Yes. So we almost always start our projects with proof of concepts and pilot projects that are no more than a week, small number of weeks long, at the most maybe 2 months. And the goal is you start with some number of data sources that are that are diverse and heterogeneous, and you actually pull those together in context of an analytic. What we don't do very intentionally is boil the ocean kinds of projects, where we say, oh, we're going to organize all of GE's data. Right? We didn't start off saying that, although that was probably in the back of our minds. What we started off saying, can we save GE money by optimizing every transaction that they make? And we think that's the right approach to these projects, is you start with an analytic and a set of data sources, and then every new analytic you prosecute, you add more data sources into your catalog, and slowly but surely over time, you've crawled all their data sources and you've organized this, but you've done it in context of the analytics that matter most to the company. Does that help? Yeah. Thank you.
そちらの青いセーターの方、お手挙げてらっしゃったので、マイクお願いします。
どうもありがとうございました。データを使う際にですね、データをクレンジングしたり、ダーティーデータきれいにしたりとか、あとは、既存の企業が持っているデータでそのままカラムを分けてあげたりとかくっつけたりとかいろいろ必要だと思うんですけども、そういったものも必要なく、テーマを使えば自動で機械学習でいろいろタグ付けしたりパターンマッチングしたりして使えるようになっていくものなんですかね。それともやっぱり、そういったデータをきれいにしたりとか、なんか作っていったりとかする作業も必要になるものなんですかね。
I think does Tamr, can they use Tamr as data cleansing tool as well, or does that need to happen separately before analyzing the data?
Yes, it's a great question. So Tamr, in the long term, is going to be a loosely coupled set of tools that you can use to do things like cleansing. Our vision for Tamr is what we call Atlassian for data. And we believe that data tools in large companies need to be more like DevOps tools, like the Atlassian suite. And so there will be many tools in that suite. So there will be things that do cleansing, there will be things that do attribute mapping, like Tamr does currently. There's no less than 20 or 30 different functions that need to be provided in any data ecosystem. I mean, we believe that the best way to bring these tools together is in a loosely coupled set of best-of-breed tools that use RESTful interfaces. And that's very different than traditional data management tools, which are oriented around a single user and oftentimes are closed platforms where it's difficult to get data in and out. We think these platforms need to be much more open. And so Tamr will have and does have cleaning functions, as you mentioned, and then there are many other functions, especially with regards to data transformation and all kinds of data warehousing and serving up the data, as well as cataloging the data. Yeah. Great question. So maybe just a couple of final comments since we have a few more minutes. The things that I've been talking about are not sexy things. They're not the fanciest. But they are very important. This is most like good plumbing in your house, right? If you don't have solid plumbing, if you don't have good data plumbing inside of your company, it doesn't matter what kind of fancy analytics you do or have. You have to have solid plumbing, and so that's what I'm really talking about here is. And once you have good plumbing and you start to get clean data out of your plumbing and comprehensive data, you kind of can't go back. You get addicted to it. It's very good.
Thank you.
Thank you very much.
どうもありがとうございました。
Thank you.